What's up, y'all? We got the relevant links in the chat. Let's get some more GROMS members. If you're watching this on Twitch, if you're watching on YouTube, come join GROMS, join our Discord, mint a GROM. We just need Solana. Let me just add another link here. Got to get the Phantom, right? Get your Phantom Solana wallet and then go mint a GROM for half a Solana. What a deal. And we're going to be working out of the Rust book, as always, for now. I shouldn't say for always, because we'll probably switch it up a little bit. Hey, Spaceman IG, welcome. Good to have you. Here's a link for where we're working out of. So this is going to be a lot of talking, right? So I'm going to try to integrate some code. It's going to be some very simple code. We'll use some of the code from the Rust book. Let me get the playground too. That way, if you don't have Rust installed yet, you can use this. Follow along. It's really important that if you're learning Rust that you write code, right? So it's good to watch videos, it's good to read code, but you want to write code. So play it, like follow along, try some things, try things that I'm not doing on stream. I'll be talking a lot through this because we're going to be going through some concepts. A lot of ways, it's kind of like a good, like, new programmer section to start with. I almost feel like we should start here because in this section, we talk about some really important, like fundamental programming concepts that are mostly common amongst all programming languages. I'll turn the music down a little bit. So we've gone through the first two chapters, and we've talked about some various things about Rust, but the big thing is we already wrote our first program with a guessing game, right? And that guessing game was kind of a good tour of like the bare bones Rust of what you need to start writing programs. But we kind of went fast through some concepts, I think, that if you're a new programmer, you may not be so comfortable with. And even if you're an experienced programmer, you may not be very comfortable with. So here we're gonna kind of dive deep on that stuff. And so if you're following along, I have the link in the chat. I'm starting in the variables and mutability section. And we're just going to start talking about variables kind of as I type out some code. So we're going to do, I'll just copy what's in the Rust book for now. So we actually know this isn't going to work. Okay, I'm going to talk line by line exhaustively about this. So let's just run through this, okay, real quick together. Look, we already have this line here giving us a problem, and the Rust analyzer is helping us out, telling us what's going on. But we're going to actually run this, even though we know we have a problem. So this is just a really simple program. I used Cargo to generate it. That's why you saw that hello world that I started with. That's the boilerplate Cargo new code. And I just cleared it out. And so I have my function, fn function, right? Main, which is generally the primary entry point for most Rust programs. We have our open braces to indicate the beginning of this function block of code, right? And so I have this let is a keyword. We talked about this previously. Let is a keyword indicating to the Rust compiler that we are declaring a variable. And why did I say Rust compiler, right? This is going to be a review. Let's talk about it just to make sure it's fresh in our minds. The Rust compiler is what goes through our code and makes sense of the Rust language that we've written, the Rust programming, the Rust code that we've written. It makes sense of that and turns it into usable, machine readable instructions, okay? And so there's certain keywords like fn is a keyword and let is a keyword that tells the Rust compiler when it comes across this keyword that something is happening, right? In this case, it's letting us know that, hey, we're declaring a variable. Or excuse me, it's letting the compiler know that we're declaring a variable. And just a reminder on the help I'm getting from the Rust Analyzer extension in VS Code. This I32 we're seeing here, I did not type that in. That is my editor, my Rust extension in my editor, telling me that it can infer that this is going to be saved as an I32 data type. We're going to talk about data types later. But just for the time being, know that you see that there, I didn't actually type that. All I typed was let x equal 5 and semicolon. So what we're saying here is let x be the name of a variable, and to that name of a variable assign the data 5, the number 5 as data to the x variable, okay? And then print line, we remember we've gone over this. This is a macro that's going to print this out to print out whatever's in the parentheses out to the command line terminal. We have this text here with the quotation marks. The value of x is colon. We have some brackets here again, and in this context, within the context of these quotation marks, these brackets are called a placeholder, and it's holding a place for our variable that we then declare or insert here, right? And that's our x variable, right? So what we're saying is here, let's create a variable called x, and to that variable assign the value of the number 5, and then print out the value of x is placeholder, close quotations, and then insert that x variable into the placeholder. And so what we should see here, if you're following along, is the value of x is 5, right? Okay, good. And then we go to the next line, and now we're saying, hey, remember the x variable we used up here? Make that be 6 now. Well, we have a red line here that's a problem. I know what it is, but let's just run this and see what happens. We have the same line running again. So ideally, if I'm reading this code and just being a human, not the Rust compiler, it looks pretty clear to me that I want to make a variable called x, assign it the value of 5. I want to print out this text and including the 5 in that text. And then I want to assign 6 to that x, and then print out the same line, except instead of it saying 5, I want to say 6. Well, we have a problem, and let's let the Rust compiler tell us what that problem is. And I'm doing cargo run. I'm in the middle of this this directory for the Rust program I'm working on, so it's going to run the code we're looking at. And so it gives us this error, right? Let x equal 5. It's saying this is the first assignment to x. And then it says x cannot assign twice to immutable variable. Okay. So what that means is that the Rust compiler is saying you cannot assign 6 to x here, because we assign it to 5. And Rust, by default, the variables are immutable. And immutable is just a fancy word, essentially, for unchangeable. Okay? So if you work in Python or JavaScript, more than likely you've seen variables, and you can just change them whenever you want, unless you call it a const in JavaScript, or I don't remember what the keyword is in Python. But you can, unless you put const in JavaScript, if you just declare a variable, you can change it all you want, right? Well, Rust is built with more safety in mind, and so unless we tell Rust explicitly, I want to be able to change x, x can't be changed. Okay, and so what we have to do is we have to insert the mute keyword, or mut, or however you want to say it. I say mute because it's short for mutable. And so now our x variable is changeable. So when we're going to assign it to 5, or assign 5 to x, excuse me, we can then later change that variable to 6. So let's run this again and see what happens. Type in cargo run. It's running, compiling. We may have a issue with our compiler. Let's see what's going on here. I'm gonna kill it. All right, again. Let's just try cargo build. I don't think that'll change anything, but it's worth a shot. Okay. Something's going on here. I'm not sure what. So this Rust analyzer doesn't seem to be running. Okay. I'm just going to kill this ID and bring it up again. Okay, so my window is going to go away for a second, but I'll still be here. Sorry about that. Let's bring our IDE back up. Okay, we're back. Sorry about that. So I'm gonna try to cargo run this again. We're still getting a build problem. Ugh, why is this happening? So normally I would take time to troubleshoot this, and I just hit this the other day. I don't remember what it was. Fixed it. But instead, we're going to move to an alternative. Just give me just a moment. I'm actually going to use that playground that I linked to in the chat, and I'll give that link again. Just a moment. And give me just a moment while I bring that up for you. I'm going to switch over to our, well, first I'm just copying and pasting this code into the playground. And then let me switch my screen here over to, oh man. Again, I managed to drop again. All right, give me just a second. We're gonna stick in Rust Playground for now. It's not nearly as easy on the eyes as my. Nope. Let me change the screen. Oh man. I am so sorry that I keep dropping. I'm working on a new streaming system that's going to be more robust. But for now, we're going to have to work with this. But I think we should be good here. Hopefully, I won't have to change Windows anymore. It seems like when I'm changing Windows, my streaming software is dropping, which is far from ideal. All right, so yes, I'm working. Oops. I am working on the Rust Playground. So be sure and follow along in the Rust Playground or your IDE if that's not giving you trouble like mine is. Okay, so we can run, and this will work now. Let's bring this up some. I wish we could get like a good dark mode, right? We got some dark. Come on, that blue. All right, so that's good. Can I get my? I can't get my terminal in a dark mode. Oh well, I guess I'll have to live with it. Okay, so, and let me just get this a little bigger. Right, okay. So we've got our code here, and it's doing what we expected right now because we have our mutable keyword here. Just a moment. Okay, so thanks for hanging with me through those technical difficulties, but we're back. And we're working out of the Rust Playground. So variables, right? They're what we use to store and reference data. There's things going on in the background, which we kind of touched on in previous streams about how their references like to addresses, memory addresses that are in your computer's memory or wherever the program happens to be running. You know, in this instance, it's running on my computer, right? Because I'm running this locally. Well, actually, in this instance, since now I'm on this Rust Playground, it's running on. It's probably running in my browser. Yeah. So that's interesting, right? Yeah, I think it's using WebAssembly. Don't quote me on that. But the Playground is a good option if you're just wanting to try out some simple things in Rust. You don't have like a full program. So let's talk about the compiler a little bit. I'm going to take this back out again.
and run. So one thing the book that we're working out of, they want to make clear, and I think it's a good idea, is that the compiler's your friend, right? You see these errors, and they're sometimes a pain in the butt because you're like, ugh, like just compile, right? But more more often than not, almost always, the compiler is finding things that is helping you write safe programs, safe Rust. Nug. Sorry, I just saw you, Nug. Bring the meteor. Welcome. Good to see you here. Good to see you, Grom here, I'm assuming. Um, the compiler's your friend. You're going to get errors. It's going to be frustrating when you're coding, but you want these errors to come out in the compiler as much as possible so they don't come out in your program when it's running. So when the compiler steps in and gives you some error, it's usually a good thing, right? And the other thing that I'll say is, I've done a tour of some of the more common programming languages, and this is the best error, the most helpful error feedback that I've seen in any language. That's one of the really amazing things about Rust, in my opinion. This basically, this is pretty straightforward, but it tells us almost exactly what we need to do. So let's actually take a moment and step through that, right? Just so we can kind of get used to seeing this. Excuse me. So while I was compiling this playground, right? It says playground because that's what this library is called behind the scenes. Okay, I never called it that, but the Rust playground calls it that. Well, it gives us this error, which we could actually open that error and see if we really want to. I've never looked at this, so let's see what happens, right? This error code is, it's just like, there's a bunch of errors. I'm not going to go through it today, but that's interesting, right? Yeah, this link to it, and then we have exactly where this error like kind of came up, where the compiler said, "Hey, this is a problem," and it tells us the line. So it'll see this is the directory that it's in, source. So if you create a new cargo app, you're gonna see this source folder, and then we have main.rs, which is the name of our file, right? And then 4 is the line number. So it's telling us right here that, hey, there's a problem right here. And 5 is actually, this 5 here is actually like the, if you count the text, which is interesting, if you're really like hurting to try to find this, if you count the character spaces, it's 1, I can't, let's try this, 1, 2, 3, 4, 5. So somewhere around here it's finding that, I think. I'm not sure. Actually, it might be here. 1, 2, 3, 4, 5. Yes. So when it's hitting this, it's trying to assign the new variable, or new piece of data to this variable that's mutable. That's what's in the error. And then so after it shows us exactly like kind of this specific error, and where it hit this error, it gives us a snippet of our code that it thinks is relevant, that the Rust compiler thinks is relevant. And it's telling us, look, here's your first assignment text. That's really helpful, right? Like this is pretty easy to figure out in this small program. But if we have a big program, that can be harder to find, right? And it has help. This is the help it's giving us. Consider making this bindable. Consider making this binding mutable by saying mute x. And then it gives us the next snippet, and it actually tells us where the issue is. So not only does it tell us where the issue is, which is great, and what the issue is, but it's also giving us a hint on how to fix it. Now, this hint isn't always what you need to do, right? Because my issue may not be that. So let's just say, for example, right? My issue may not be that I want X to be mutable. What I should have done is create a new variable, right? And this just depends on what I'm trying to do with my program, right? If I'm trying to create 2 variables, then I should have just created another variable with a different name. But Rust is going to try, emphasis on the word try, to figure out what it is you're doing and try to give you some helpful information on how to fix it, which is amazing. again, it's not always right, but at the very least, you're going to find out, you're going to have an idea of where, like, what's happening, what the issue is, and where it's happening. And so, I don't know why it's not letting me drag this. Trying to move this again. It's not moving. Yeah, so that's great. And the Rust compiler is, it's going to be I think of the Rust compiler as a coach, right? Because it's gonna frustrate you when you're doing things the wrong way sometimes, but it's gonna help you write better code. All right. So another topic, and I might just have to read. There we go. All right, we got some. Another topic is constants, right? And I even talked about them in reference to JavaScript earlier. The constants, they're, here we had a variable, right? 5, right? And we want to be able to change it, so we add a mute. But what if we don't want to change the variable? So let's do. What am I doing? Well, we need to do like string. We're gonna stick to a number. We're gonna stick to a number, right? Because I don't want to confuse things right now. We'll talk about strings and all that stuff and data types when it comes up. So const cannot be changed, right? But what's the difference between const name equals 2 and let x equals 5, right? Just when it comes to mutability, there we know that we can't change x because we tried to do that earlier, right? And that's when we got this error down here. But there are some subtle differences. One is like constants, and we're not talking about scope today, but putting this in your head, like constants can be declared in any scope. And they can be global. So like, let's say you're writing this big program. Let's just say we're writing a program and we need to know what blockchain we're going to use, right? It doesn't work this way, but let's just like make this up in our head, right? Well, we want this big program. Let's say it's a game. The game is going to have all sorts of code, right? You're going to have all different types of text files that are code. It's going to have code for the hero. It's going to have code for the villain. It's going to have code for the level. It's going to have code for the health. It's going to all sorts of stuff, right? But one thing that's constant is we want to build this game on the Solana blockchain. So in order for that fact to be saved as a variable that can be, we shouldn't even call it a variable, right? We should call it a constant. In order for that piece of data to be accessible to all the game, one way to do that would be to save it as a constant. And so constants can be in global scope. The other thing with constants is that we have to annotate it, right? So let's just number of viewers. Right now we have 2 numbers. We have to annotate it with whatever. Actually, let's do this, right? With whatever data type is going to be. So, and I'll do just looking at the Rust book just to follow, like what's the word? Like best practices, I guess you could say. We'll capitalize the constant, which is kind of common in other languages too. And so we also have to tell the Rust compiler very specifically what kind of what data type this is, or what kind of data this is. So in this instance, I'm using U32, just shortcut for now. If you see U32, it's an unsigned integer, and all that means is it's a whole number that can only be positive. Okay, that sounds like a lot to know about, but if you've seen like int in other languages, it's essentially the same. Okay, We'll talk about what U32 and I32 and U16 and I16, like what those are later. But just know that this is declaring it as a number, that whole number that can only be positive. Okay, and so reading from the book, one paragraph, it says, I'm going to read the paragraph and I'll talk about what it means. It says the last difference is that constants may be set only to a constant expression, not the result of a value that can only be computed at runtime. So basically what that means is like this has to be explicit. We couldn't say, let's say, const sorry. That's a ridiculous variable name, but I'm using it. Let's make x mutable. So here's the thing, right? And this is part of Rust that was difficult for me, not having like much, not having a whole lot of like, I mean, experience in general, but specifically like low-level systems programming experience. Things like there's a certain amount of information that's knowable at runtime, right? So what if like instead of us just declaring x, man, I wish I had our guessing game program up. Let's see if I can grab some code from that real quick. So in our guessing game, we had some code here. I'm just going to copy and dump this in. And I'll walk through this again just really quickly so we know. Let me grab our parse statement. Where did my parse statement go? There we go. Okay. So we're gonna change this up a lot just to make it sure it's clear. So we're just gonna yank this whole guessing game code. So let's run through this real quick, okay? So let mute guess equals string new. Okay, and all that, just real quick, I'm not going to go into deep dive because we did this in one of the previous videos where we built this program. This is creating an empty variable called a guess that's an empty string called guess, and then we're elsewhere in this code we'd prompt the user to enter their number, and then we'd grab that number with this line of code, and then we're changing that number from like string text that's just like characters into the specific number. Okay, so here's the thing. Here's the reason I bring this up, right? So guess, we don't know what guess is going to be at runtime, right? Or excuse me, at compilation time. When the Rust compiler goes to compile this, it has no way of knowing what the guess variable is going to be, because the user's entering it, right? So when the user enters it here, let me just do this because it's annoying me. Okay, so the user is going to be prompted for a guess, and then we're going to save that guess here as a string, and then we're going to try to turn that string into a number. And if it's not a number, in this case, it's just going to close the program. But if it is a number, guess will become a number. And then so guess is like whatever number they enter, right? Well, with the const, let's try this out, right? We're just going to take that guess and try to double it, right? And then this is like a nonsensical program, right? Like, why would we want to do this? But we're just doing this to try to exercise this idea. Yeah, so if our understanding is correct, this should throw us an error because double guess can't be, like, we tried to make double guess a const during compilation, but it has to be known, right? It's taking guess, which before this program runs and before the user enters it, guess is a mystery, right? We don't know what's going to be assigned there. Oh, yeah, I got to bring in, I got to bring the use standard, or what is it? IO. STD IO. Yes, right? This is exactly what we saw, what we were talking about. Oh, I forgot to put my exclamation point in the macro here. Sorry. All right, let me just run this again just to clean it up, okay? We got the error we wanted, but I got another error because I didn't put an exclamation point in the print line. So I cleaned that up. Okay, so let's go through this again, right? This great feedback we're getting from the Rust compiler. Error, yada, yada, yada. Attempt, we can look on this by, clicking on it. We're not going to. Attempt to use a non-constant value in a constant. Const double guess is a U32 equals guess times 2. That was our line, right? Line 14. Consider using let instead of const. So now, if we just do this, that should work, right? Again, some nonsensical code here, just to exercise this. Oh, it's mad because we don't ever use a guess variable. And I've got to enter a guess, which I can't hear. All right. Yeah, I forgot in our playground we're not able to enter information into the terminal, which stinks. So all that to say, so the code ran without an error, right? Apologize, we're not mighty to where we can like interact with this program, but it's not like an amazing program anyway. So yeah, so we got through the first two sections of the variables and mutability subchapter of the Rust book today. Let's look at shadowing for a moment here. So yeah, let's see. We could probably use the book's code to talk about shadowing, and I think we're gonna knock out this concept, and then we're going to call it a day, and we'll pick up in 2 days on Twitch, where we do data types. So that'll be fun. We'll get to talk about some of this stuff we've kind of been glossing over. I mean, that's what this section really is about. Okay. And give me just a moment here to enter some code from the book. I could just copy and paste it, but where's the fun in that? All right. So shadowing refers to the fact that you can take a variable name like we have here and use it more than once, right? So we first take a variable called x and assign 5 to it. And then we take x here, which is our 5 up here, plus 1, and assign it to a new version of x. Actually, let's just remove this for now. So what we have, it's interesting. Let's do it. Let's just break this up. I want to get 2 instances of this line here and just run it again. So let me just sorry, I want to be able to see all this at once. Okay, so we have our let x equal 5. Pretty straightforward, right? Value of x. We've got our x in the placeholder. Value of x is 5, right? Well, this is interesting, right? This is why it's called shadowing. Because we have this new version of x here, right? We've said, hey, there's a new variable called x on this left-hand side of the assignment operator or the equal sign, right? And on the right side, we're saying, okay, to the new variable of x, assign x plus 1. It's kind of strange, right? Because I thought x was now a new variable because we declared it over here. But what it's still able to do, it's able to shadow this version. It's able to maintain this version of x, which is 5. And so we see this, what happens here is that 5 gets added to 1, and that gets assigned to the new version of x. And when we print out x, we get 6, right? And so I'll read a line from the book. A couple lines, actually. So you can declare a new variable with the same name as a previous variable, right? That's what we did here. We declared a new variable called x using the same name as this variable called x. Rotations say that the first variable is shadowed by the second, which means that the second variable's value is what the program sees when the variable is used. Rotations say that the first variable is shadowed by the second, which means that the second variable's value is what the program sees when the variable is used. And now let's get our bracket back in here. Our little block of code. So the program first binds, and I'm reading from the Rust book again here. The program first binds x to a value of 5, then it shadows x, right? Because we're shadowing x here, right here. This part is the shadowing. We're shadowing x, by repeating let x equals, taking the original value and adding 1 to the value of x. So x is then 6. And now then within the inner scope, let's go ahead and run this so we can see it while we're talking about it. Then within the inner scope, the third let statement also shadows x, multiplying the previous value by 2 to give x a value of 12. When that scope is over, the inner shadowing ends and x returns to being 6. Oh, I didn't like that. What happened? I'm not sure why the compiler killed it. Right. So while it's doing that, it seems pretty straightforward. I'm not sure why it's giving us an error. Kind of going to ignore it for now. It might be a playground issue. Actually, we do have an alternative, which we may take advantage of if we're still getting an error one more time. All right. Yeah, it looks like it's still giving me an issue. Let me. Oh no, it worked this time. Okay. I probably had a syntax error of some kind, but we're not going to worry about it. Well, I'm kind of curious now. Why did I have a syntax error? Let x equal 5. Let x equal x plus 1, right? That's all straightforward. We're in a block of code. Yeah, I don't get it. It's very strange. Okay, so now it works. All right, whatever. Okay, so let's just talk about what's going on here. Why we see a 12 and then see an x, right? Right here. First we see a 12 and then we see an x. That's kind of weird. What's going on? Okay, so this is a bit about scope, right? Let's walk through this again. Let x equal 5, and then we're shadowing x by creating a new variable called x, and we're assigning to that the previous version of x, which is 5 plus 1, so x equals 6, right? Then we're going to this block of code, and this block of code, these braces, mean that there's a scope within this like scope, things can happen that won't necessarily affect outside of the scope. But since this block is contained within this function, it is affected by the code outside of its block. Okay. So what happens? Well, we know x is 6, right? Or excuse me, we know x is 6 because that's what it was here, right? So 6, this variable x here is 6, and then we're shadowing again, just like we did up here, except within this block. And this is creating a new variable called x. It's assigning to it 2 times the previous version or previous value, 2 times the previous amount of x. So it's turning into 2, right? Or excuse me, 12. And then so we print it, we get this 12 down here. The first one that we print, the value of x in the inner scope is 12. But then what happens? We get another print line and we get a 6. Why is that? Well, here's what happened. That block of code ended and that scope ended. And so since that scope has ended, everything that happened in here doesn't really matter anymore. Like this got printed out, which is fine. It came out to the output here, standard output. But this variable change that happened, the outside of the scope, this code is not aware of it, right? And so when we go to print x again, it's not taking the x that was created here. It's referencing the x that was created here. And like understanding this, it's a little tricky, but it's important, and it's going to become even more important as we start to learn work with like borrowing and stuff like that, and references and all sorts of fun stuff. This is kind of the stuff where we really trip up on Rust if we're new to systems level programming. But I hope that shadowing is clear from that. I hope that mutability is clear from today's stream. I hope variables are pretty clear, right? Like not like every data type, but we understand what's happening here, right? We're binding. There's the term that the Rust book used, so we should probably use that. We're binding the value of 5 to the variable that is called x here, right? We use constants. We understand the difference between an immutable variable and a constant, right? We have a little bit more flexibility with with mutable variables, because we don't have to declare the data type. We're able to rely on data type and inference, which I think we talk about later in the Rust book, but if not, I will definitely talk about. We have to say explicitly, this is going to be a number of this kind, right? Let me just bring in a line of code from the Rust book just to touch on constants for a second, right? We're putting this U32 because we're saying that this constant is going to be of this data type. And then we have to give it this number that can be predetermined prior to the program running. It has to be knowable at compile time. So while we're there, let me just take just a minute or two to get in your head about runtime and compile time, right? Those are two different times. Compile time is when the Rust compiler is looking at your code and turning it into instructions for the computer to run. Runtime is when your program is running. Now, with our guessing game that we made in previous videos, compile time is everything when we type cargo run and we see all that stuff happening, or if I click run here on the Rust playground, when we see that progress bar, that's compile time, okay? And that's the Rust compiler going through your code and turning it into instructions for the computer. And then there's runtime. And runtime is while your application is running. So if you think about our guessing game we programmed, the runtime is while, like, me as a user, I'm entering guesses and I'm trying to get that guess. That's the runtime. So just know that if a constant needs to be knowable at compile time, that means it has to be clear what that value is going to be before the program is running. That's another concept that, like myself, I had a hard time understanding until I really dug in. So, all right, that I went way longer on the section than I expected to, but I think that's good. We had some technical difficulties, so thanks for hanging out during those. I may just bought myself some YouTube editing time to get this posted, but hopefully we can paste it together easily enough. I'm gonna recommend, as always, that you write your own Rust code based on the book, based on these videos. These videos are meant, and streams are meant as a supplement to the Rust book. I recommend still you read the Rust book. You can read it for free in the links I provided, or you can buy a copy on Amazon. I like to have both personally, but you can use it completely for free, which is great. So I recommend, I don't know in what order is going to make sense for you, to either watch these videos and read the book. Maybe it makes sense to read the book first and then watch the videos, but keep learning Rust. Come join the GROM's Discord, Minted GROM, and learn Rust with us. I think we're making some good progress. I feel like I'm starting to get my groove of the streams despite technical difficulties, and our system. Our system's coming. We're gonna get a new. I'm gonna have a new system for streaming that I think is gonna be better. Okay, Untied Beer. Great. I'm glad to hear that. You've been here from the beginning, so I'm excited. You're still around. I totally get the time zone's not ideal, but thank you for the kind words too. All right, Rustations, Groms, whatever you are. Thanks for watching. Thanks for hanging out. Go write some Rust and let's get after it. All right, talk soon.